Hi, I'm Nicola Petty, and this is Evidence Segment 1, What Constitutes Evidence. You'll see in the green box on the first page it says an important principle, and this really is the key idea from Inference. Right, this is one of my favourite lectures, so I'm rather sad that we don't lecture in a way because I like doing this. So what I would do is I would take a bag of chocolate bars into the lecture theatre with me, and you can see on the right there's a picture there of a Pinky, a Mars and a Crunchy bar. And I would tell the students, I have a bag of chocolate bars, 1/3 is Pinkies, 1/3 is Mars and 1/3 Crunchies. And I also assume that there's hundreds of bars in the bag, so even if we remove one, it's not going to noticeably change the proportions in the bag. And what I do is I draw one out and they have to guess what it will be, and if they're correct, they get the chocolate. So a person puts up their hand and says, say, Mars bar, and I take a bar out and it's a Pinky. I go, oh, so I put it back in because they don't get it. Okay, the next person puts up their hand and they guess maybe a Crunchy. And I put my hand in, draw out a Pinky, and oh, no, that's still not what they wanted. And then third time round, someone guesses a Pinky and they get a Pinky, and fourth time round, someone guesses a Pinky, and the class starts to laugh at this point because they have worked out there's something funny going on here. And in fact, the problem is that I had lied. The bag did not include 1/3 Pinky bars, it included only Pinky bars. And so they would have always got Pinky, no matter what they guessed. The students were told that the bag contained 1/3 Pinkies, and so if you look in the box there, that gives the probability of getting each of the different events that happened. So you get one Pinky, that's a 1/3 chance, and so everybody knows that was pretty likely. And then 2 Pinkies, again, that's pretty likely. You've got 1 chance in 9 that you'll get 2 Pinkies in a row. And in fact, there's 1 chance in 3 that you'll get 2 somethings in a row, so you wouldn't think that that's a bit suspicious at all. Then we get 3 in a row. Now there's 1 chance in 27 of getting 3 Pinkies in a row. And then we get 4 in a row. So going, oh, that's 0.01 probability, or about 1%, or just over 1% probability of getting 4 Pinkies in 4 drawers. And then when we get to the 5th one, then you're getting down to 1 chance in 1,000, or 1 chance in 729, which is getting quite unlikely. So think to yourself, when would you have become suspicious? So most people get about suspicious at 3 or 4, and they definitely should be suspicious at 4 or 5. And so they should be, because the probability of getting, say, 5 Pinkies in a row, if in fact 1/3 of the bars are Pinkies, is actually quite small. And this is also how probability and statistics come together. So we'll have a look. Implications. So the thing we assumed to be true was that the proportion of Pinkies in the bag is equal to 1/3. Now, so we had that. That's what's known as the Null Hypothesis, is that's how it is. And then we get a result. And if the results don't fit with the assumed population, that means that our initial assumption about the population was wrong. We had to change our ideas about the distribution of chocolate bars in the bag. But we also have to think about how much evidence we need before we can legitimately change our minds. So this is the idea, is that we use this idea of evidence. We use what we know about probability to help us to decide whether what has happened is from chance or from, say, sampling error, or if our initial hypothesis is false. Now, you might want to do this with your family or flatmates and see how many Pinky bars it takes before they get suspicious. This video was brought to you by Statistics Learning Centre. Visit our website for more resources to help you learn.